Hello guys, today we are going to continue subtracting mixed numbers. I told you that the algorithm of subtraction in principle does not change. That is the most important thing, is to see the same denominators. If these denominators are different, then we need to make these denominators the same. But I mentioned that there is an alternative approach to subtracting, wherein we can utilize a different technique and still arrive at the correct solution. It is ultimately your decision, but let's establish a starting point using an illustrative instance. All right, let's proceed. And we're going to go over the subtraction algorithm. So 5.3 must be subtracted 2.2. So guys, in order to subtract mixed numbers or mixed fractional numbers, you need to bring to a common denominator. I'll show you another way to subtract, of course. The rule governing the denominators remains unchanged. Mixed numbers cannot be subtracted unless the denominators are the same. Therefore, their denominators must match for subtraction to take place. You're going to have to add to the common denominator every time. So, what are we doing here? We're writing down that the denominators are 5 and 15, and we're looking for a common denominator for those denominators. That is the lowest common denominator. Let's remember how to find the lowest common denominator. I have the numbers 5 and 15. I choose the larger of those numbers, that's 15, and I check, is 15 divisible by 15? Yes, it is. Is 15 divisible by 3? Yes, it is. As a result, the number 15 serves as the common denominator. Now please, let's find our additional multipliers. I divide 15 by 5, that's 3. I divide 15 by 15, that's 1. The additional multipliers allow me to bring this fraction to a denominator equal to 15. What am I given as the outcome? The answer is 5 complete. I multiply 3 by 3, that's 9. And 3 times 5, that's 15. And then minus 2 whole. 1 I multiply by 2, that's 2. And 1 I multiply by 15, that's 15. And now that our denominators are equal, I can subtract the whole parts separately. Whole parts in the fractional parts separately. 9/15 minus 2/15. Now I can do the math very easily. 5 minus 2, that would be 3 whole ones. 9/15 minus 2/15, that would be 7/15. The answer provided is approximately 3.7 with an insignificant deviation. But I previously mentioned that there is an alternative method that is frequently employed. What exactly do you have in mind for our discussion? So I can write down 5.3 3/5 minus 2.2. What can we do now? If the condition is very important we must fulfill, that is, to bring mixed numbers to a common denominator, then what can we change in our algorithm of the solution? The fact is that we can convert a mixed number into an improper fraction. If suddenly you are stressed by these integers and you are not comfortable working with them. So, we convert the number 5.3 to an improper fraction. Let's remember how to do it. So 5 I multiply by 5, 5 I multiply by 5. And plus 3. The denominator stays the same. Minus 2 I multiply by 15. And plus the numerator 2. The denominator still remains 15. Consequently, the numerator I obtain is as follows. 5 multiplied by 5 is equal to 25. And when we add 3 to 25, we arrive at the sum of 28. 28/5 minus 30 is what you get when you multiply 15 by 2. And you can add 2 to 30 to get 32. 15ths. And we've got two fractional numbers that we need to subtract. Do you know how to subtract fractional numbers? What do you have to do it? Again, find the least common multiple of 5 and 15. Notice that this condition is exactly the same, which is 15. The complementary multipliers are 3, and the complementary multiplier is 1. So, what am I doing? Again, I multiply 3 by 28, and 3 I multiply by 15. 3 groups of 28 each add up to a combined total of 84. 3 I multiply by 5 is 15. Minus 1 I multiply by 32, it will be 32. When I multiply a number by 15, the result is always 15. Take note of the fact that the denominators are identical. Therefore, our course of action is clear. We must correct this denominator. I shall record it as 15, and then I shall deduct 32 from 84. The outcome is 52/15, which amounts to exactly 52/15. But we said that if the answer is an incorrect fraction, we need to isolate the whole number. Let's isolate the whole number. 52 divided by 15. That would be 3 whole numbers and 7 more in the remainder. That is 7/15. I found the same answers as before and noticed their similarity. So we solved this problem correctly. But what is the inconvenience of this process? The main point is that, listen carefully, I obtain large numerators, and that's where you can potentially make a mistake, but it ultimately depends on you, and I have confidence in your ability to subtract mixed numbers. So that's everything for today. Farewell, until we meet again.